Hi, welcome to xmTuition, where I help everyone with their physics homework. Like yesterday, my third auntie's daughter asked me to explain this question to her. So in this question, we are asked, of these four, which one represents a useful resonance? Option A, tuning a radio receiver to a particular radio channel. I suspect a lot of students nowadays don't know what tuning to a radio channel means. So let me do a bit of explanation, yeah? So radio stations broadcast the programs using radio waves. But there are so many different radio stations. How do we choose which station to listen to? This is where the interesting part is, yeah? So each radio station broadcasts their program using a different frequency of radio waves. So 95.8 will be broadcasting their program using radio waves of 95.8 MHz. Yusan-san will be broadcasting their program using radio waves of 93.3 MHz. So every radio receiver has a tuning circuit inside. When you rotate this knob here, you're actually adjusting the resonant frequency of the tuning circuit. So when I tune my tuning circuits to say 95.8 MHz, it means the transfer of energy from the 95.8 MHz radio waves to my tuning circuit will be the most efficient. So even though there are radio waves of other frequencies, those other radio waves do not transfer the energy to my tuning circuit. That's how I can choose to listen to only say 95.8. So yes, option A is definitely a resonance phenomena and it's a useful one. That's why option A is the correct option. What about option B? The vibration of a loudspeaker stand when it's playing sound of a particular pitch. So you have a loudspeaker and you have the stand. So the stand usually have some rubber pads, right? Some cushion. So these cushions are going to make the stand a kind of oscillatory system. And the loudspeaker is going to be vibrating at the same frequency as the sounds that they are playing. So the loudspeaker is going to act like a periodic driving force. That's why when it's playing sounds of a pitch that matches the resonant frequency of the stand, then this stand is going to be vibrating violently. So is this a resonance phenomena? Yes, it is. But it's not a useful one. It's a nuisance. That's why we don't choose option B. Option C is about refraction of light, which has nothing to do with oscillations. Option C is just nonsense. Option D is about induced current in the iron core of a transformer. Again, this nothing to do with oscillations. It doesn't matter what frequency of alternating current you're running here. The amount of eddy current has nothing to do with the frequency of the alternating current. So this is again not a resonance phenomena. Perhaps it is useful for me to highlight to you here that when we're talking about resonance, there must be a just right frequency. As the driving frequency goes from the lowest to the highest, the amplitude of the oscillation must increase and then decrease. So if there's this increase and then decrease in the amplitude of oscillations, then it's likely to be a resonance phenomena. But if it occurs at the highest frequency, or if it occurs at the lowest frequency, then it's probably not a resonance phenomenon. I hope my cousin will continue to ask me questions, then we can all improve together. Ta-ta!